All right, we're at number 4 now. I just did 3. I think this is the last one where you have to graph one. This one says, Tobias is creating a mural for a project in art. Part of the mural includes a sequence of pillars that decrease in height. The first pillar is 243 centimeters, so that's A1. And it says each subsequent pillar decreases by a factor of 2/3. So factor, that word right there means multiply. So this is telling us it's geometric. We're multiplying, not adding or subtracting in that case. So R is 2/3. It says graph the height of each pillar in terms of its position in the sequence of pillars. So this would be like whatever pillar number you're on, and this would be how high. So this is pillar number, and this is height. So the very first one we know is 243, and then it's getting smaller. So 243 is the highest we have to reach. We have 14 lines to do it, so just so you know, the minimum you have to count by, if you take how many you need and divide by how many squares you have, I have to count by at least 17. I'm going to round up to 20. Every little square will be 20. Okay? So like if 0 is here, this will be 20, 40, 60, 80, 100, 120. See how I'm counting by 20? 140, 160, 180, 200, 220, 240, 260, and 280. Okay. And then the pillar number, I'm just going to do what we have been doing and put like 7 of them here. Every other line is 1. I don't know how many it's going to fit, but we know the first one is at 243. So that's just above the 240. And then we know it's 2/3. So 243 times 2/3 is 162. So the next one, number 2, is going to be at 162, which is just barely over the 160. And then we do it times 2/3. We get 108. So at 3, it's going to be 108. So here's 100. That's 120. So 110 will be in the middle. So just so under the middle. Times 2/3 again. Remember, that's our rate, so that's what we're using every time. Then we're at 72. So here's 80. This will be 60, 70, 72. Times 2/3 is 48. So if this is 40, this is 60, there's 50. I'm just going right below that. Times 2/3, that's 32. So here's 20, 40, 30's in the middle, so just above that. One more time. Times 2/3. And we get 21, just over 21. So notice how it's curved because it's not a linear function. Yes, sir? Maybe, I mean, I didn't write down the time, but maybe 10 minutes, give or take. It could have been a little less. He said he was in the parking lot or something. Yeah. Thank you. Bye. Alright, so that one has our graph. And again, because we're talking about pillars, you can't have part of a pillar, so there's no need to connect them and make them a curve, because you can't have a value in the middle of the dots. Alright, the next one says, a sequence is represented below. It tells you term 1 is -10, and then it gives you a recursive formula. Remember, the recursive ones are just what do you do to the last term to get the next term. So to get a term, you take the last term and add 3 is what it's saying. Okay? So the type of sequence, if we're adding, is what? Is it arithmetic or geometric? If we're adding. Arithmetic. Alright, and then it wants the first 5 terms of the sequence. Okay? Well, they gave us the very first one, right? term 1 was negative 10. Okay, and if we add 3 to that, let's see, we're at negative 10, we add 3, we're at negative 7, so that's our next term. If we add 3 again, we're at negative 4, add 3 again, we're at negative 1, one more, because it said 5 terms, we've got 4. So we add 3 one more time, and we're at 2. So here's our first 5 terms.
I need Damian Munoz and Michael Goff to the front office at this time. Damian Munoz and Michael Goff.
Okay, so that one's a little easier than the graphing ones, just because you have to graph. Now, that being said, on the test, the graphing ones are probably going to have graphs as answer choices, because y'all know your tests have been multiple choice. So you can't really say graph this in a multiple choice question, so they'll give you graphs to choose from. You'll just have to make sure you knew how to graph it so that you could pick the right one. Okay. All right, this one says the sequence is represented below. It tells you the first term is 1 over 16, and it tells you to get the next term you multiply by 2. See how there's a 2 in front? Remember, when there's 2 in front of something, it means multiply. So if we're multiplying, what type of sequence is it? Geometric. And it also wants the first 5 terms. We know that the first term is the 1 over 16, and it says times 2. Okay? So I'm going to take 1 over 16, and I'm going to do times 2. So our next term is 1 over 8 times 2. Our next term is 1 over 4 times 2. Our next term is 1 over 2. We got 4 now, one more, so times 2. And we got 1. So here's our first 5 terms of the sequence. Y'all see what I mean by these are a little bit easier than the ones where we had to graph? The key part on these is you have to recognize that this one was a plus 3, and this one having the number right in front, that means times 2. So that's how you recognize if it's arithmetic or geometric. Because the recursive formulas, they're not a formula in the sense that like the explicit formula is. They're just a what do you do to the last term to get the next one. Okay. So number 7 says a function representing a sequence is shown below, and it says f of x equals negative 5 times 2 raised to the x. Identify the type of sequence and then the first 5 terms and the common ratio. So we wrote this at the very top of our front of our review. So I'm just going to peek right there. See how this is something times something with an exponent? Which one of those types is it? Which one is something times something with an exponent? Yeah. So it's definitely this one, right? So remember, your first term is your starting point. Your second term is your rate. That's your common ratio. Okay? So here, the type of sequence is geometric. The first term in the sequence, we have to be a little bit careful here, but it's starting at negative 5. But does this show n minus 1? It just shows an x, right? So doesn't that mean that if this is supposed to be n minus 1 and it isn't, that this is actually the previous term? Do you know what I'm asking? Did I word it well? It's kind of hard to... the common ratio, I'll answer that one next. The common ratio, which is r, is the 2. Okay, that means we're doubling. But you know how on a graph you always start with 0, not 1? This is your 0, not your 1. Okay? So this is a of 0. So if I doubled that, what would my first term be? If I double negative 5, what do I get? Let's try it. Negative 5, I'm going to double it. I get negative 2. 10, I mean. So that should be our A1.